So, we're going to start talking about sequences. And this is just an introduction to what sequences are and how we use them. And I'd like you to look at this problem and see if you can figure out both parts. So, the first part says find the next three terms. And so far, the pattern is 1, 4, 7, 10. And then could you please go ahead and find the next three terms, assuming that the pattern continues. And then when you have finished that, because I think you can figure that out pretty easily, see if you can find what you think the 100th term is. What number will go there? Okay, think about it and try to do it smartly and see if you can come up with a number for the 100th term. Take a pause in the video and then come back and check your answer. Okay, so hopefully on the first part, you found 1, 4, 7, 10. You noticed that each of the numbers was increasing by 3. So the pattern that we're looking at is that we need to add 3 to each number, right? So the next term would be 13, and then 16, and then 19. Okay, no problem. So now it says, can you find the 100th term? And I truly hope that nobody just kept adding threes until they got to the 100th term. That is time consuming. It's easy to get it wrong because it's easy to miscount a little bit. So obviously that was not what I was hoping that you would do. I was hoping you would think about it a little bit, okay? So let's try to see if we can figure that out. Okay, so let's look at, the first term is a 1. That's not really telling us anything, but then we know the second term is a 4 because we added 3 one time. So the second term we got by adding, we took 1 and then we added 3 a single time for the second term. And then for the third term, so like this is the first term, right? Not only is it the number 1, it's also the first term. This is the second term. And then 7 is the third term, and now I'm out of space. So 7, we took 1 and we added 3, and we added 3 again. For the third term, we added 3 twice. So see if that continues, right? So like, let's look at, let's see, 1, 2, 3, 4, 5, 6. The last term we found was the 7th term. So can we get 19 by taking 1 and adding 3 how many times? Once, twice, 3, 4, 5, 6 times, okay? So 19 is the 7th term, and we're adding 3 6 times, 1 less than the term, okay? And yeah, that's right, because 1 plus 18 does equal 19, okay? So for the 100th term, we should take 1 and add 3 99 times, right? Not 100 times, because on the 7th term, we added 3 6 times, 1 less. Okay, so if you got 1 plus 3 times 99, 298. And if you got this in a different way, great. Okay, that's totally fine. That's just the way that I thought about it. But if you got 298, you're probably on the right track. Unless you just kept adding 3 over and over and over again, because that's not a long-term solution. Please don't keep doing that, right? Okay, so this list of numbers is called a sequence. Okay, it's a sequence of numbers. Basically, it ends up being a list of numbers. But the true definition of a sequence is it's a function whose domain is the positive integers. It doesn't mean that every sequence will have all the positive integers in them. No, definitely not. What it means is that the function will be defined using basically a counter, the nth term, the first term will be n equals 1. The second term will be n equals 2. So the numbers that we're plugging into the function will be the positive integers, okay? And that's what makes it a sequence. Let's take an example. Just give a little more space. Okay. So find the first 4 terms and the 100th term of the sequence defined as a sub n equals 2n minus 1 over n. So before we actually do the problem, I just wanted to point out a little bit. So a sequence is often going to be defined this way. This is called an explicit formula because it really tells us, just in terms of n, which is that 1, 2, 3, 4, it tells us how to find each number in the sequence explicitly. So if we know that we want to find the first term in the sequence, we put in, it would be the a sub 1. That means it's the first term in the sequence. We put in n equals 1 and we evaluate and get the number. Okay. A second thing is to show that this is a sequence and not just a regular function, then these brackets are sometimes used. So you're going to see that those bracket notation. All right, so for us to find the first 4 terms, we need to find the first term, okay? A sub 1 is the first term in a sequence. So a sub 1 for us, that means that n equals 1, okay? So all we have to do here is plug in 1 to our formula. So 2 times 1 minus 1 over 1. That looks like 1 over 1, just 1, okay? A sub 2, okay? That is the second term in our sequence, and that means that n is equal to 2. So that's 2 times 2 minus 1 over 2, okay? So 4 minus 1, so 3 halves, okay? A sub 3, that is the third term. And that means n is equal to 3. So 2 times 3 minus 1 over 3. So that is 6 minus 1, 5 thirds. That's the third term, 1, 2, 3. We also need the fourth term, so I'll come over here. A sub 4, of course, is the fourth term. N is equal to 4. So 2 times 4 minus 1 over 4. Looks like 7 fourths. Okay, when we have a formula, an explicit formula like this, a sub 100 should not be difficult or intimidating, right? Because we actually have the formula given to us, unlike at the beginning when I had to kind of figure out the formula in order to figure out the 100th term. So if we need the 100th term, that would be, that means that n is equal to 100. So that's 2 times 100 minus 1 over 100. That looks like 199 over 100. And there's a little intro to sequences.